calculator, to get a character string, again, I'll just do it again here. You do backslash, and then whatever word or string of characters you want, backslash again. That's the key above return. It'll disappear, and now you've made that string either a parameter right now, so we haven't defined it, so it's just equal to 1, or you can make it a function name, right? So we want a function name, so it's a function, so control 9, and we'll do x. And so now we're about to define this piecewise function. So equals. To get a piecewise function, you're going to hit control A. And for every additional piece that you want to add, you just keep hitting control A. So how many pieces do we want for this one? So I just need to hit control A one more time. So I've got 3 lines for 3 pieces. What about for PC? Anyone figure it out? Control Shift A. Control Shift A. Control Shift A for PC. Mac Control A. PC Control Shift A. Yeah.
How do you get it to do 3?
You just keep hitting it until you get as many as you want. So the first time you do it, it'll give you a 2-piece function, and then each additional time, you'll just keep adding 1 piece. Are we good? Okay, so now we're going to, like I said, solve this problem and put it in. So beginning at -7.5, we have a constant rate of change of -2/9 over the interval -7 to -3. Who thinks they can do the first piece of this? Kevin.
I got 5 minus 2/9 parentheses x plus 7.
Okay, so what do you want to multiply by x plus 7? -2/9. Okay, -2. I just didn't hear it right. Okay, so -2/9 x plus 7 is what I heard. Okay?
And you can do plus 5.
Is that what you got for the first piece? This is our point slope form. Remember? Rate of change times what's x plus 7 represent? Change in x, right? And so what does that whole first expression represent? -2/9 times x plus 7 is the change in y, right? Change in y is our constant times the change in x. And then the whole thing is old y plus change in y gives new y, Brett. We're just defining the function, we're not graphing it. So in the next line, we'll do the y equals the function and it'll graph it. So now we're just defining the function. Okay, so now we have to specify it's over this interval -7 to 3. So what you do in graphing calculator is you write if. If. So we're saying this is true if -7 is less than, so that's our lower bound, x. And then, so these are called the breakpoints. The breakpoints are where the one function stops and the next constant rate function starts. And so what we'll do is we can't include the breakpoints in both definitions on either side. So we'll include the right-hand endpoint in the definition. So less than or equal to -3. So we'll include the point on the right, but not the one on the left. Okay, so less than or equal to, on Mac, it's option less than, so option shift, or just, I think it's just option comma. What is it for PC? Anyone got it? Control shift comma. Control shift comma will give you the less than or equal to.
Yeah, keeps putting brackets wrong.
Yeah, mine does that too. I put -7 and I try to put a less than, and then it puts parentheses around the whole thing and then a less than.
I just erased it and did it.
Yeah, start over. If there's something else there, then it'll try to do that. So can you just start that part over after the if and erase it and try again?
It's control shift comma for PC.
So it's control less than, which is shift comma, right? Other issues, are we good?
Question about the x plus 7. I know there's a point slope form, but where did the 7 come from the interval?
Okay, so it's the change in x from -7 to x. So how do you get a change in a quantity? The final value minus the initial value. So it's x minus -7. So yeah, let's do that.
Okay.
What's that? Why is it what? Because this is the interval over which we want that function. over the interval. See, so here's the thing. Sometimes ordered pairs represent a point. Sometimes it's not an ordered pair. It's an interval, so you have to read carefully. The context tells you whether that means a range of x values or a range of some type of value or an ordered pair, x and y. Does that answer it, Mosey?
How do you not put parentheses around everything?
Erase and start over.
It was because there's a space. Don't put a space.
Don't put any spaces. No, don't put any spaces.
Yeah. So just write if and then don't put a space. Just start -7. That's what.
Okay, so going on from here. So now in our next piece, we're going to have, what's the constant rate of change? -5.6 times change in x, which is? What is it? What's the change in x on this one? Nope, not x plus 7 and not x plus 4. Y plus 3, Jonathan.
Because that's where it's starting again.
Yeah, so it's kind of helped to have a picture. I lost my pen. Oh, that would be quite bad. Oh no. Shoot. Okay, we'll have to make do here. Put the screen up. Yeah, no markers. Oh, thank you. Thank you. So yeah, so you have to imagine, so when we're doing this, first interval is from -7 to -3, right? And then the next interval is from -3 to 4, and then from 4 to 9. So we had some beginning point, -7.5, and that's our AB for the first piece of the line, okay? And now when it has a slope or a constant rate of change of -2/9, okay? So is that like this, or is that like this? The lower one or the upper one? -2/9. So do we understand constant rate of change? What does -2/9 mean?
It's going right down to and then right.
That sounds like something you learned in a previous course. So can you talk about in terms of what we've been learning? -2/9 is the constant rate of change.
So it'd be the change in y.
Okay.
So you're changing y only by 2, and then you're changing x only by 9. So it's the top one.
Okay. Yeah, so what is this? This is the relative size of changes in y to changes in x. So if x changed by 1, would y go down more or less than that?
Less.
A lot less, right? It would only go down 2/9 of what y did. So, right, so the relative size of changes is -2/9. Okay, so we're going to come down like this to here, like this. Okay, and now we're going to start again. And this is for our second one. This is going to be our point, A and B, right? So what is A? That's why we put x plus 3 in that next line, see? So it's this AB that we're going to use. So the question is, what's B? Ross wants PW of -3. Agree with that? Is that the B value at -3? Because what's it going to do? So if you put in, if you're in this line here, it's going to call upon the function PW -3. Well, let's finish it and then we'll talk about that. So then if, what's our interval? -3 less than x less than or equal to where? 4, right? Okay, constant rate of change in the last part. 8/7. Change in x. X minus
Would that be 9 now?
x minus 9. What do you think?
Oh, it's 4.
Linwin.
So there's 4.
X minus 4. Dissension. Ryan. What do you think?
I don't know.
So it's our AB again. Right? So we're going to have going down something like this. I don't know where this is. We have this AB for this piece, right? So I'm asking, what is A? The x coordinate of that starting point. X minus 4. Okay.
4.
Yeah. So here in this region here, we're saying this is the value of x. So we start with the change in x, right? What's the change in x from 4 to x? This is building our linear function again, right? That's how we started. Change in x would be x minus 4, right? So that's the change in x for this particular interval, x minus 4. We've learned a lot. Don't let it fall out. All right, so plus what? We want the b when x equals 4.
PW.
PW of 4. And then if 4 is less than x, 9. Okay, questions about the piecewise function or using graphing calculator? Alexander?
Why do we have to write PW for PW negative 3? Why?
It's because we want to. What do you want to do instead?
Well, wouldn't it be the same as just like 4 or 9?
So PW4 equals 4, is that what you're saying? It's the same thing?
No, the PW4 would be the same as 9.
He's saying we solved it.
Is it-
What did you do to get this number? You got a number 9, you're saying.
Yeah.
What did you do to get 9?
I plug in 4
Into what?
into the piecewise function,
Okay.
and then it gets 9.
So you plug 4 into this.
No, the one under it. Because in the very top one, you're like plus 5, and now it's
Okay, so you can't just look for a pattern. So the reason we want to do this is because it's very convenient. See, so we could figure out what that value is. We could put -3 in here and get a value there. But we don't need to, because we can just let graphing calculator do it for us. It's very convenient. It's using our function notation, so we don't have to do those calculations. So it's help. We want to do that. Okay. So how would you calculate PW4? So how would this thing do PW4? So let's do that. So let's put, or in fact, let's just do 5. Okay, so in the next line, do PW. You don't, when you use, from here on out now, whenever you use PW, you don't need the backslashes. Whenever you do PW, it'll remember that you've defined that as the name of that function. So I'm going to put PW, and I'm going to put 5 in there. How is it going to calculate what that is? How is it going to get PW5? Sterling, what's it going to do?
It's going to go to the first one first. 5 plus 7.
It's going to go to the first line?
No. It's going to put -3 in the first one, -3 plus 7. Something like that.
I'm going to put 5 in here. If I put 5 in there, what's it going to do?
They're just going to substitute the x for 5.
Gilbert.
It'll look for which piecewise it'll fit into.
Right. And which one is it?
The third.
It's going to go here because 5 is between 4 and 9. So it's going to go here first. And what's it going to do with the 5?
It's going to calculate it.
It's going to calculate it. How does it calculate it?
Well, it's going to calculate it, but then it's going to go to PW.
How does it calculate it?
It plugs into the equation.
Yeah. So it's going to put 5 in here, right? It's going to put 5. How is it going to calculate this? Now what's going to happen?
Well, it's going to go to PW4 and then get it from PW4
So
to the second one.
It's going to put 5 in here, and it's going to calculate this. In order to calculate this, it's going to,
Put 4 to the second.
it's going to go up here. You see? And it's going to get PW4, it's going to be up here. with what as x? 4. It's PW 4. And how's it going to calculate that? It's going to go up here and put -3 into this one. You see? So it's going to use all 3 lines. If I put a 5 here, it's going to land you. It's going to start here, and it's going to use the second line to get that, and then it's going to use the first line to get that, and it's going to tell us what the value of the function is there. So there it is. -0.57935.
Did you get the backslash to go away on the first equation?
Before you
I don't, well, wait, how did you type this when you put it in PWX?
Okay, so the first time,
Yeah.
if you want to use a character string to define, everyone listening? If you want to use a character string to define either a parameter or a function name, you hit backslash, then the character string, and then backslash again. Then the backslash just disappears, and it gives you the character string. After that, all you have to do is write the character string, and it recognizes it and knows the one that you defined. You don't have to do it every time. You don't have to do the backslashes every time. Do you guys work?
Yeah.
Does it work?
Yeah.
Okay. We got it? Okay. Other questions about what just happened here? All right, so then we get, yeah.
Because of this, is it saying whatever X value and that you always started at -7? Or is that just how you call it? How you find it?
I don't understand the question. Are you talking about plugging 5 in?
Yeah.
So what's going to happen here is it's going to
Is it
do
just
this line. It's going to graph that line, or it's going to define that constant rate, that linear function between those x values. You're taking a piece of that line on
I
that
understand that concept.
Okay.
But just in general, is it saying like you're always starting at -7 and you go to whatever number you put in, or is it just how you find the value when X was
Yeah, this definition gives you the output of the function when you give it an input. Yeah, so if I put in 5, it gives the output of this function at 5. Mariana? Yeah. Okay. I'm so glad you asked. How do we graph this now? Oh, that would be bad. Y equals PW of X. And we should get this piecewise function.
You don't have to put backslashes for that?
No, only the first time. So when you're making a character string, you do it the first time, backslash, character string, backslash. Everyone listening? Is everyone listening? To do a character string, first time you do backslash, character string, backslash. The backslashes disappear, and you have your parameter or function name. Every time after that, you never have to do backslashes again. Everyone got it? Okay, cool. So here it is. So here we are between -7 and -3. We got our, remember, constant rate of -2/9. And then between -3 and 4, constant rate of -5/6. And between 4 and 9, constant rate of whatever it was.
So, I don't know if you're going to this or not, but like, are we gonna like do any point on this?
What's that?
Are we gonna do any point on it?
I don't understand any point.
Like, say if I want, like, you know, you use n equals, like, how do we do that for
I don't understand what you're saying.
okay.
You want a movable point on the graph? Just do y equals n. Y equals piecewise of n. So we want the x value to be movable. No, that doesn't work. Why doesn't it work?
Or don't you have to put n?
So why didn't that work? What do I want? I want a point, right? That's just graphing horizontal lines. If I want a point, what do I do? Control 2, and I want n, PWN as the y coordinate.
So you could graph that entire line to be moving.
What do you want to do?
Can you go back? Saves my
Okay, so there's your movable point. Letting x be n, and I need to reset n if I want to see the whole thing. So from say -10, 10. There's my movable point. And how did I do that? So you knew this from your project. plot the point, x value is n, which is controllable, and then you always want the y value of pw corresponding to that, change n, it'll move around. Okay, Shayna, did you have a question?
Oh yeah, can you just go to like my name project now?
Okay, so I posted homework for Friday, and there's a written portion that you're turning in Friday, but then there's a little project relative to this that's due Monday, okay? But I've already posted it, so I want to go over the project. Any more questions about this? Yeah.
So if we wanted to have it like nicely, like how in our homework I would have like the nice flat horizontal lines, is that way to do that and graph them? Like for the tax brackets, so it have the nice.
Oh yeah, we'll do it. Yeah, sure. Well, so if you want each piece to be a horizontal line, what would it be? If you want each piece to be a horizontal line, what would your function definitions be?
You would just put it
Here, how do you get a horizontal line? But what graphs a horizontal line? Constant, right? So if we just put constants here, right? So if you just put constants here and then cut them off and make them segments, so you. Okay, so your little project for Monday is this. So here I'm showing you the first two lines of your thing will be just like this. I've defined the breakpoints. So it starts at 0. The first point is at 0. Then there's a breakpoint at 2. Well, so there's the first breakpoint's called BP1, and then BP2, BP3, BP4. You all know how to do the strings to make parameters, right? And then the rates of change. The first rate of change, the second rate of change, the third rate of change, and the fourth rate of change. Okay? So there's a command line beneath here. That's your task. It's your task to define the function f so that when you graph the function f, it will create the piecewise linear function according to how you set the parameters. So I can come over here and I can say, oh, I really wanted breakpoint 1 at 4 and breakpoint 2 at 7.8. Breakpoint 3 is okay at 11, and then this one at 18. And I made a mistake here. The rate for the second interval is negative 1.2. The rate for the third interval is 4. And that one's okay. So now I just changed some of the breakpoints, changed some of the rates, graph it, and it changes it. Okay? So your task is create the command line that defines f of x, so that all you have to do is you can just change the breakpoints as you wish, change the rates as you wish, and it'll graph the resulting piecewise function. Okay? So that's your task. Yeah.
How do you have like the breakpoint one and stuff? Do you literally just type it in, or?
It's defining a parameter. Just backslash, type out the word, backslash. Does everyone get it?
Do we have to do one of those for each one of those words?
What's that? Yeah, there's 8 different parameters there. You're defining 8 parameters. Okay? So you're going to do it 8 times. But then after that, you don't need the slashes. You just type BP1, and it'll pop up.
Does it understand what a command would be?
No. So you're defining. This is a parameter you've defined, a character string that now means a parameter. So by using the backslashes and the parameter string, you just said, I want to call something, I want this to be a value. And then you set it equal to, say, 4, or set it equal to 5, or set it equal to 1. It's like a variable, like x. But you're using a whole string, like a whole word, instead of x or z or whatever. You use a whole word to do that. Use the backslashes to do the word. Okay, so that is, so on the assignment itself, I put a couple of examples, just like I showed you a couple examples here. So there's been confusion in the past that my intention was for you to create those graphs. So here's what you'll see when you load up the assignment. You're not creating these graphs. The whole point is, this is just 2 examples of what would it look like if you changed the parameters for the breakpoints and the constant rates accordingly. Okay? So you're creating a file that can create any piecewise function starting at 0. That's what you're creating, according to how you define the breakpoints and the rates in the first 2 lines. If you're unsure about the task, read this. It's all spelled out here. Read carefully. I also made a video. Okay, I also made a video to explain it. Watch this video. You got 2 videos now that explain it. But there's been a lot of confusion in the past. Lots of people, they send their assignment in and it looks just like these 2 graphs, right? These are just examples of what your program should be able to do. Do you see?
So you want our command lines then?
One command line.
Okay.
One command line. No, you're going to send me your file. You're going to send me your file. I'm going to send an email on Sunday. You're going to reply with your file.
The one command line doesn't include the graphing line, right?
Nope. I'm showing you the graphing line here. Y equals f of x. So it's just defining f of x is the one command line that you do. Okay. Where are we? I don't know. Let's try this. There we go. Okay. So, piecewise linear functions. What's the general idea? Function has a constant rate of change. It's different constant rates over different intervals. Okay, so I want you to, by observing this graph, I want you to interpret what you see in the context of constant rate of change. There would be lots of things you could say. So talk to the person next to you. Interpret what you see here in the context of the meaning of constant rate. Go.
Yeah, so negative 2, x is less than 2. Yeah, that's right.
Okay. Constant rate of change. Let's see. Shannon, you're up. Tell me something, anything that makes sense relative to constant rate of change here.
Doesn't have pieces.
What's that?
Doesn't have like pieces like.
Okay, it doesn't have pieces. What about constant rate of change?
The change is 2.
You think it's 2. So why 2, and what does that number mean?
Well, it's a change in the file or a change in.
Okay, so it's, and what do we mean by changing y or changing x?
Like big 2 points.
Okay, so it's like you're calculating the slope. Austin?
Changes in y are twice as fast as changes in x.
You kind of mixing 2 together there. Changes in y are, got a little too complicated. Changes in y are just what? Changes in x?
2 times.
Just 2 times. 2 times changes in x. Yeah. So if I take the change in y here, change in x, how do I get the corresponding change in y? It'll be double that, right? It'll be double that. But what about if I take a really small change in x? It'll still be double. It'll just be a smaller change in y. Okay, good. Somebody else? Let's see. Sterling.
K is 3, not 2.
Let's do it. I think you're thinking this goes through the origin. Yeah, see it? Yeah, okay. Other interpretations or observations?
Can we say like it's, well, I don't know if it's really have changed, but that's only constant within that interval?
Okay, so we only see a particular interval here, so we don't know what happens outside of that. So Austin also says something about 2 times as fast. What can you say about what is 2 times as fast? Where's Sean? Sean.
Pretty much just look over there about that someone can come up with.
Okay. So what about 2 times as fast?
So y is changing 2 times as fast as x.
Y is changing 2 times as fast as x. What do you think? Yeah. Back to this question. What does that represent? Peter.
Represents the k constant, like
Okay.
how fast y is changing for everyone changing x.
Okay. And if we okay, so that's kind of going back to this. If we're comparing and measuring delta y, what is that about?
So, like, we're defining changes in y, like using changes in x as our units.
Right. Yeah. So if you use the change in x as your unit, you'd always have 2 of those, right? 2 of those. Okay. Also, what are the magic words? No one said yet. Relative size, right? Relative size. It's the relative size of changes in y to changes in x. And this, they're always 2 times as great as the change in x. Okay? So this is the graph of y and x, and it's showing that constant rate of change, right? So there's another type of graph that we can use to show a constant rate of change of 2. And that's, instead of graphing y here, we'll graph the rate of change here. So I'm going to do another graph over here. And now instead of having the y value vertically, it's going to be the constant rate of change vertically. So what will that graph look like? At
2.
At 2, okay? And now instead of y, it's just showing the rate of change. So these two are showing the same constant rate. This one is actually graphing the constant rate. This one is showing how y is changing at that constant rate, see? Make sense? So those 2 graphs show the same thing. So for every interval of x, you're always showing a constant rate of 2. See that? Same constant rate over every interval of length x. Same thing here. For every interval of length x, delta x, you show that same constant rate of changes in y or twice changes in x. Make sense? So those 2 graphs both show a constant rate of 2. So here's now I'm going to start with a constant rate graph. So it's a piecewise function. So this is like we were talking about, right? So if x is less than 0, the constant rate is -1. If x is greater than 0, the constant rate is 1. So what I want you to do is come up with the graph of f. The graph of f of x, if that's the constant rate piecewise function. Go, see if you can do it. So what's the graph of f of x? Show me, I want to see it. So you got to understand constant rate. What does a constant rate of -1 mean? What does a constant rate of 1 mean?
Constant change.
Show me.
So the rate's changing.
No, the rate is constant.
It's negative change. It's below 0.
Yeah, that's what calculus is about. We're getting there. Yeah, so you're talking about that rate of change function changing.
Yeah, if that was
That's what calculus is about. That's what calculus is about. We're getting there. That's good.
Yeah. Yeah.
See graphs.
So it's
So
piecewise function.
Good. All right, so what does a constant rate of change of -1 mean? So who can explain what a constant rate of -1 means? It means that
Whenever x changes, y changes by -1 times x.
right. So whenever x changes, what is y? It goes down how much?
-1 times whatever x goes.
How can you say that? That's absolutely right. And so it goes down how much? Does it go down x? So you're all saying this,
Goes down negative delta x.
right? But what does that mean? So what are the layman's terms? Every time x increases, y goes down?
Same
It doesn't
amount.
go down 1.
Same amount as x
The
times.
same amount that x we increased x by. You see? We increased x by a certain amount, y is going to go down that same amount that we increased x by. That's what that says. Okay? And what about a rate of change of 1?
So first, it's going to be the field that's just over repeat.
Tell me your name again. I forgot.
Me?
Yeah.
Connor.
Connor.
So the exact same value. That is
So you're going to change x, and what's y going to do?
the same change that x did.
Yeah, it's going to go. This function is going to go up the same amount that you increased x by. That's what a constant rate of change of 1 is. Okay. So some of you drew this. Right? So if you increase x by a certain amount, y will go down that same amount. That's what a constant rate of change of -1 is. If you increase x by a certain amount, y will go up the same amount you increased x by. Constant rate of change of 1. Comments? Someone had something different? Yeah?
Yeah, well, I did it as like, I just drew it because it was wrong anyways. But like, I knew how y-intercept for like the left side of it.
Yeah.
I like negative something. And then like the right side of it, I did it as positive.
But you think it's wrong?
Well, I don't know, like that's
Something like this? Oh, wait, sorry. Something like this?
Yeah.
What about that? Does it work? Good work.
You can't know how your original function looks just by your rate of change because there's so many possibilities.
So this is okay? Are you okay with this?
That fits this rate of change,
Yeah.
yes.
Okay.
So you can't know what your function looks like without.
What about this one?
Yes.
Does it work? Yeah, right. Many possibilities, right? So there's lots of ways we can draw a rate of change of -1. We can kind of put it anywhere we want. Same with +1. Okay? So there's many possibilities. This is one of them. This is one of many possibilities.
And I had another
Yeah, sure.
like say for like the other possibilities, would you still have to do like a circle, like as in like, you know, like segments and thing? Oh, yeah, like when you draw one at like negative, like your y-intercept's at -3, that's a point, and then like on top of it, there's a circle, or like it would be a hole, I guess. That's the proper term for it.
Right. So yeah. So here it's we don't know. So suddenly the rate is jumping, and that causes a right. It could cause a discontinuity here, or we don't know what's going on there. Right. Yeah. It causes an issue. You have to. So you're honing in on. There's a problem here on the y-axis. That's right. Okay. So your tax table. So how does this thing compute tax? Oh, I want my pen. How does it compute tax? So suppose you made $26,585. How do you use the tax table to get the tax? Yeah, you find what interval you're in there. So it would be here, this one. And then most of you are single, so it just tells you that. So where's that number come from? Aaron? Or you have a different question? What?
I was going to continue off, but you're supposed to do the computers.
I didn't hear you, sorry.
I was just going to continue off, like how you compute it from there.
Okay, so yeah, where do these numbers come from was my question. Is that what you were going to say? No. Where do the numbers in the table come from? Christian.
Like a certain percentage of, like based on how much you make.
Okay.
Well, everybody pays the same amount of tax. Like with the homework assignment was $8,000. So everybody will pay 10% on that first time of all. And
Right.
you add that to, I like a higher percentage for your next amount of money, whatever the interval is.
Exactly
Then you
right.
add, so it's progressive taxes.
Okay, he did his homework, right? He did his homework. Good. So progressive, that's it. It's a progressive tax system such that you're taxed a different amount for different amounts of the income that you make. Okay? You're taxed a different amount for different amounts of income that you make. So suppose, well, first of all, so we talk about this function, input and output. What's the input into this function? What does X represent?
Taxable income.
Yeah, your taxable income in the year, right? So this is how much you make in a year. Okay, what's the output?
How much you pay
Tax
tax?
due.
The percentage.
Tax rate.
Percentage of tax that you have to pay on the whole amount of what you make?
No, well, no, because you're at different levels. So it's
Right.
not
So what tax rate do you get when you put in how much you make?
Your highest.
Yeah, so it's like it's the rate on the last dollar that you made, right? It's the current rate for the amount that you made. But tell me your name again?
Steve?
Yeah, so Steve explained it correctly. If you're over the course of the year, so here's January 1st, December 1st. Okay, say you make $100,000. So you make that $100,000 gradually over the year, right? So at some point in the year, maybe, I don't know, January, February, somewhere, you hit $8,000. How much tax do you pay, or what's your tax rate for those first $8,000 made?
10%.
Everyone's going to pay 10% on that. And then somewhere along the way, maybe May, April, you're going to hit 34,000. So those dollars from 8,000 to 34,000, you're going to pay 50% on those dollars. This is how it works. Okay? And then at 82,000, maybe you're November, October, something like that, you hit 82,400, you're going to pay 28%. And then for those last up to 100,000, you're going to pay the 28%, right? So when you put in 100,000 into this, the rate that you get out is the rate on the last dollar that you make. Okay? So how are these rates like a constant rate of change? They're the relative size of what compared to what? So this 0.28. How is it a relative size? How is it a rate of change? Somebody new? Brian, do you know?
That's the relation of your tax percentage in relation to the amount of dollars you make.
Okay, so it's tax percentage to how much you make?
Or tax rate.
So it's tax owed relative to a dollar that you made.
So that's saying for that last interval, for every dollar you make, 28 cents of it.
That's right. So it's the amount of tax owed relative to a dollar that you make. So if you make $1 in that tax interval, you're going to pay 0.28 of that dollar, right? So this is exactly what we've been talking about. That tax rate is exactly what we're talking about. It's a relative size of the amount of tax you pay to how much money you make. Okay, so your Friday's written homework, listen up. Your Friday's written homework is more questions regarding the tax. It's actually 10 more exercises this time. And then there's one more question just building a piecewise. And then that project, that grad preparatory project you can get started on, you'll be replying to my email after Sunday. Ask me to come up here now. Oh, I have a quick announcement about recitation and quizzes. So, my intent is to possibly drop some quizzes or make an adjustment at the end of the semester. But if there's a higher average on the Thursday quizzes than on the Tuesday quizzes, I won't do that. Okay? So Tuesday people, You can't share what's the material covered on the quiz with the Thursday people. If I see higher averages on the Thursday, no adjustments, okay? No adjustment, no dropping. See you Friday.
You go, I looked it up and like so jealous. I found the place where you just had to go over that.
Okay. How about I'll start tomorrow? You agree?
Yeah.
Till Thursday.